Okay, so let me give you the background about this park. So why it came into the market and how it actually works, the architecture part and all I'll try to cover today. Okay. Okay, so you might have heard the word big data. Because of this one only spark in the market, I can say. What is this big data actually? Why do we call it as a big data? When I say big data, in layman terminology, huge volume of data, I can say. Okay, so who is generating that data actually? Who is generating that data? So that data is actually generated by different applications. That there are different sources are there for the data generation. Even human beings are also generating knowingly or unknowingly that we are we are like responsible for generating that data. Okay. Um, so you if you take like these applications, right? Are these like different social media applications are like you see LinkedIn, Twitter, and Skype, um, Google Plus, like that, YouTube, every Outlook, and everyone like is generating the data. I can say here. Okay, so to handle, okay, before going into that one, when I say big data, uh, big data can be described based on five V's actually. So, variety, volume, velocity, value, veracity. Okay. So, since all these characters starting with V here, so people call it as big data is defined based on five V's. Okay. The V full form is each V full form is mentioned here. Okay. So, what is volume? When I say volume in terms of big data, how much volume of data you guys are generating or a particular application is generating. That is nothing but volume. Okay. Coming to the second part, velocity. Velocity is nothing but how frequently you are generating the data. So for every 1 second, or for every half an hour, or for every 1 hour, or it's a batch load. So how frequently you guys are generating the data. Uh, that we call it as a velocity. And third one is actually value. Okay, so before that one, before the value, we need to understand about the variety as well. So what kind of data you are generating? You are generating CSV files, JSON files, XML file, or like a Parquet file, or like semi-structured, or like unstructured files. What kind of files you are generating there? So that describes actually the variety of data, I can say. And the second one, last but one is veracity. So veracity is nothing but accuracy, I can say. Accuracy is nothing but like when you generate 1 TB of data, right? So out of 1 TB, how much of data we have junk information in that. So we have to filter out all that junk information, right? So that we call it as a veracity. Okay. How accuracy the data is. Okay. And the last one is okay, you're generating the data and we are processing that. What is the benefit that industry or company or the application is going to get out of it after processing that data? So that we call it as a value. So let's say if Twitter is processing the data, or if let's say Facebook is processing the data, or let's say Walmart is processing the data. So what is the benefit ultimately they're going to get it? So that we call it as a value. So big data is actually defined based on all these five V's. Okay. So see, you don't need to understand all those things very much. Uh, I'll just give you the background why Hadoop actually came into the market. Okay. Okay. So after 2003 or 4, I can say after 2000, I can say slowly the companies started generating more and more data, I can say. So you guys remember like after 2002 or 2003, like Orkut and the Facebook started like in the market freshly. So at that time, like they were generating huge volume of data, I can say. Okay, even YouTube as well. YouTube also started like became famous at that time after 2000s only. Okay. So uh, if they wanted to process the data, we used to have some traditional data warehouses were there actually. When I say traditional data warehouses, uh, can you name like some of the traditional data warehouses we have at that time? Legacy data warehouses, I can say. Oracle is one of the data warehouses we have. SQL Server is one of the data warehouses we have. So Teradata is one of the data warehouses we have. Postgres is also one of the data warehouses we have. So they used to process the data using on-premise uh, data warehouses or databases, I can say. Okay. And they used to store that in a data warehouse. So what was the problem at that time when they started processing with the traditional data warehouses or databases? Say, you guys know how, I don't know how many of you worked with the traditional databases here. When I say traditional databases, like let's say if you take Oracle as a database writer, they will install this Oracle in one single system, I can say. One single system. Oracle database will install in a one single system. Okay. So if you want to process this data, like some application data, only this database, single system will process that actually, the entire data. Whether it is a 1 TB of data or 2 TB of data or 5 TB of data, irrespective of the volume, only this particular system will process. If the system capacity is not enough, they'll try to increase the RAM capacity and hard disk capacity for this particular on-premise systems. Even if it is a SQL server also, same thing. Let's say, so the RAM capacity or the ROM capacity, they will decide based on uh, data forecasting, I can say. When I say data forecasting, next 5 years, how much volume of data that your company may generate. Based on that, they'll plan this like on-premise databases. In the olden days, I'm talking here. Okay. See, at that time in 2004 and 2005 or 2003, um, YouTube, LinkedIn, the Facebook, Orkut, they started generating actually very huge volume of data. I can see in petabytes, not even terabytes, in petabytes actually. Okay, so the traditional databases or traditional data warehouses could not able to handle that much of data. Maximum they can handle like 400 GB or like 400 TB, I guess. Okay, they can handle 400 GB of data maximum. So now the people started thinking actually how we can process that data, that much volume of data. At that time, actually, the Hadoop came into the market. Okay, see, in the case of traditional databases or data warehouses, only single system is actually processing your data. Whether you for extracting and transformation and generating reports on top of that one, everything is managed by on-premise database only. Okay, of course, ETL applications are there. ETL applications ultimately stores the data in a traditional databases only, right? So at that time, Hadoop came into the market, and that too it was open source actually, and it was started by a duck cutting at that time. Okay, so he took the inspiration from the Google file system, GFS, short form we call it as a GFS. So he took this white paper and he like started this Hadoop application, I can say. Okay, so the first Hadoop application was released with 0.1.0 released in 2006 to handle that much of volume of data. Okay, now what is their concept in the back end? How they used to process, how they used to manage that volume, that much volume of data. So remember here, Hadoop has actually two parts. So why we call it as a Apache Hadoop is he started this project actually Hadoop project, and he handed over it to Apache company, which is an open source company, and Apache company did the development on top of his idea, I can say. Okay, it has two things actually. One is HDFS, that is Hadoop Distributed File System. We are not using these things in nowadays. I'm just telling you for like just to have a background of this one. Okay, we used to use this one HDFS. When I was in my previous company, we used to these HDFS and all. Now nobody, almost the companies which are using HDFS is very rare, I can say. Most of the people are switching towards the cloud. Okay, there in place of HDFS, they started using S3, GFS, and the your ADLS Gen 2 in this one Azure. Okay, of course. Okay, so Hadoop distributed file system for storing that data. Okay, and for processing the data, they used to use MapReduce. MapReduce. I'll tell you the sample program also. MapReduce sample program. I'll show you how it exactly works. Okay, their concept is actually like this, guys. Their concept is like this. Let me erase this one. Just a second. No. Let's say if you have 100 TB of file, or let's say 1 GB of file or 1 TB of file is there. Now you wanted to process this data. See, 1 TB of file, if you want to process with the help of the traditional databases, it's very difficult actually, because we have a limitation, right? Maximum they can handle like 400 TB of data. But what if you have 100 TB of like more than 400 TB of data? So every day you're generating petabytes of data, right? Then in that case, let's say if you have 1 TB of file, they'll try to divide that file into blocks. When I say blocks here, this 100 TB or 1 TB, they'll try to divide that into 64 MB blocks. Memory, they're trying to divide that into smaller memory chunks. Okay, initially it was started with the 64 MB in Apache 1.0, I guess. So they'll divide this data into multiple chunks. Okay, and backend they follow actually master slave architecture. What is this master slave architecture is? So to manage to divide this one into blocks and to manage or to monitor uh, the processing and all, they used to have some masters actually. And on top of masters, we have some slaves. See, when I say master and slave here, master is one of the system, slave is also one of the system. Both are different systems, I can say. Okay, one master is enough, or multiple, of course, like to manage that redundancy and all. I mean, to manage that failover and all, they used to have multiple masters here. I mean, if something goes wrong with this master, immediately they'll switch to this master. Even if something goes wrong with this master also, they'll switch over to this one. So that we call it as a failover scenario. Okay. So just for safer side, they'll try to maintain multiple master. When I say multiple master, not thousands of masters. Only like two, three masters they'll maintain in the backend. Okay. So that is nothing but master. What this master will do is this will divide actually the data into smaller chunks. Okay. Now this is keeping the data now. Okay. After that, what it has to do is it has to distribute each block, okay, to the each slave. Okay, now if 100 TB of data is there, we have to store this 100 TB of data in some location, right? Some location in the sense. So we have to store this data in a hard disk, right? So where is this data is actually getting stored? So this is getting stored in a they'll try to install this HDFS software in all the slave nodes. Okay, let's say we have 1,000 like systems are there here. 1,000 CPUs are there here. So each CPU, let's say 1 TB of memory is there. Hard disk memory, I can say, not RAM. Think that RAM is only 4 GB or 8 GB of data capacity. Okay. So when you install this one, HDFS software in all these systems, okay, and they will try to connect all these systems in a network. This is what they call it as a Hadoop cluster. Okay, if they have 10,000 systems like this, 10,000 slaves like this, now they have 10,000 into 1 TB of storage overall. Okay, they're calling it as, they're treating this entire thing as a single unit. Now my Hadoop can process 10,000 into 1 TB of data. It can store that much volume of data. That means the more the data you have, the more the number of systems they'll increase here. Okay, now, okay, so what this master will do is, this master will try to will decide actually where to store the data, which system has to process that, and how to like uh, uh, like uh, execute that program. Everything will be taken care by this master only, and slaves will just listen to this master, and they process the data, and finally they store the data in their respective hard disks. This is what the architecture or the process they used to follow when the Hadoop was introduced in the market. Okay, now also we are following the same architecture. Even in the Spark also we follow the same concept, master slave architecture only. And fine, of course, they took that inspiration from Hadoop only, but in a different way, not in the traditional way, I can say. Okay, so this is what I was talking here. Uh, 1 second. Hmm. This is what I was talking here. So this is the client. Client means you. Client means it's you or the programmer, I can say. So just submits the program to the master node. Hey, I wanted to do do so and so activity. Okay, so I mean, so on activity means, like, let's say I have a file. In that file, I wanted to just calculate the word count. How many words are there in that file? I just wanted to calculate. So that is my program actually. That is my requirement actually. So he will just submit that program to the master node. What master node will do is, master node will generate actually key value pairs from it. Key value pairs in the nothing but backend, it will try to generates 64 MB of blocks, and it assigns that each 64 MB data to each slave nodes. And backend, it stores the data. After processing it, it stores that data. Okay, this is the architecture of the Hadoop, I can say. Okay, now Shiva, they were storing the data in slave nodes. That is okay. Storage part is clear. Like for me, how do they used to process that data? What is that programming language they used to use to execute this to process this data, I can say. So for that, we have actually um, we have actually map reduce programming. I'll show you the sample program also, a bit later. But they used to use here map reduce programming, so which is purely written in Java, I can say. You have to write that program in Java language only. Okay. So that is about the, I mean, at high level, that is the map reduce. I'll show you anyway that sample program as well. But don't worry about that one. Okay. So when Hadoop 1.0, slowly the versions got increased, guys. Here, I mean, the with the improved part, right? They started like releasing the new versions here in the Hadoop, I can say. So initially, we used to have only for processing the data, or for cluster management. Cluster management is nothing but this master has to control all these slave nodes, right? So that is what we call it as a cluster management. So this entire thing we call it as a cluster. All these systems are interconnected actually in a network. Every system can interact with any other system, I can say, because ultimately they have to process the data. Right? They have to interact each other actually. So everything is managed by master only here. MapReduce, everything is managed by one system, I can say. So HDFS, they used to store it in a I can say slave nodes. Now after that, they slowly started introducing that ARN concept. Actually, what this ARN does is, it will try to manage that clusters actually. Okay, so we have MapReduce. I mean, they're just trying to reduce that burden from the master, and they introduce a new process called AN here. The full form of AN is at another resource negotiator. So what it does is when you submit a program, actually, how many slave nodes are available at that particular point of time? How many CPUs are available at that particular point of time? Based on that, it will try to allocate the task. So that is separated with the MapReduce programming. Okay, I mean that responsibility is distributed between the systems here. Okay, so the Hadoop 2 was actually released in 2013. And later, actually, the AN got introduced, which has become a bit popular, I can say, when compared to the Hadoop 2.0. And 3.0 also got released a little later. So 2.2 has AN, and slowly, like after AN got introduced right in the market, like many applications actually, I mean, for batch processing, they started one application. For interactive processing, they started one application. For streaming, they have one application in the sense like they have one ecosystem, I can say. Like for this one reporting, they have one application. For in-memory processing, they have one application. Like that, different uh, like different in a Hadoop ecosystem, we have different things are there here. I mean, if at all, if you want to handle streaming, they used to use actually this one Storm or Flink, like that. Okay, so if at all, if you want to process the batch, then they used to use MapReduce. These are all part of the Hadoop ecosystem, I can say. So you use any of these application. Okay, ultimately, AN is going to maintain that resources. So, who is going to do what? That is completely decided by Anne. Okay, because in a company, you'll be having streaming process, batch process, and the graph means like this reporting. Everything is managed by different. Everything is managed by this Anne only here. This is just a cluster management case. This doesn't do anything, but whatever the request is coming from the master, it is just plan it accordingly, and it will try to tell to your slave nodes, oh, hey, you have to execute so and so, you have to execute so and so task. So based on that, it will decide actually. Okay, so the typical flow looks like this actually, MapReduce programming. I'll show you this one in a perplexity actually. Just before your class, I just asked perplexity to give this sample program for the um, word counter. Okay, let's say I have a file, I have a text file actually. How many words are there in the text file? I just wanted to calculate. That's my requirement actually. So what they used to do is map reducer is nothing but mapping and reducer. Those two are two different topics actually. Mapping is nothing but generating that key value pairs. Reducing is nothing but see ultimately when you write even SQL also, what do you do with SQL? So you select that required columns and you do group by, you aggregate the things and you process the data in that way, right? The same way here also, when Hadoop was introduced, it will try to divide that data into first key value pairs. On top of that one, reducer program actually does that aggregation, and whatever you wanted to do, you can do with that reducer program. Okay. So uh, what I can see is every time you have to write mapper program and reducer program for every file, I can say. For every file, maybe like when I say every file, for every requirement, for every file, the requirement might be different actually here. Okay, so for that, they used to write actually lot of Java programs. So for that actually, Java knowledge is required. They need more Java knowledge people from the market at that time. So when I was like trying to learn for Hadoop, right, in 2016 and 17. At that time, one of my friend already got into IT and he was started working on Hadoop actually. I called him one day. So, hey, like his name is Banu. Like, hey, Banu, like I wanted to learn actually Hadoop. Like, what is the prerequisite for that one? What is that course that I need to go through? Then immediately he told me, hey, Hadoop is it's actually completely based out of Java. You have to have knowledge on Java. That is what he mentioned. And that too, they started taking only experienced Java people at that time, because the people just learned the Hadoop, like they might not be having that knowledge, right? So the complete processing used to happen on Java. That's what I wanted to tell you here. Okay. So they used to write the programs like this. Uh, of course, I've shown here in a Python based mapper and reducer program. But let me ask here. Give me Java based program. Yeah. So this is what they used to write it here, like this. Okay. So this is main method, and this is they write actually um, uh, this one, what I can say, reducer class separately and the mapper class separately. So this much of code they have to write it, I can say. This is the reducer class, and this is the mapper class, I can say. See here, they clearly written here. This is mapper class. This is reducer class. So what mapper does is mapper actually generates key value pair. I'll show you here like this. Okay. And what reducer does is shuffling and sorting will be done by the reducer. When I say shuffling, let's say I have the data in a first partition, in the first mapper like this. If I ask you, hey, what are all the different products are there based on the country information, then you have to group that data, right? So for that, data shuffling should happen actually between the nodes, I can say. That shuffling and this sorting will be done by the reducer. And finally, you'll get output like this. I mean, this is just a typical program I'm telling you. Okay. Um, so we have the ecosystem, guys, actually. Hadoop ecosystem we used to have actually. When I say Hadoop ecosystem, for batch processing, we used to have Hadoop, MapReduce programming. For streaming, actually, we used to have Apache Star. And for interactive processing, actually, we used to have Tej. Tej is also one of the Apache product, I can say. And we used to have for graph in the sense like a reporting purpose, I can say. We used to have Apache Graph. Okay. So we have all these things in market, and people started everyone, whoever is like generating huge volume of data, that companies actually started adopting this Hadoop technology, because it was a free, it was an open source actually. So you don't need to pay any license for that. So you just need to download it from the Apache website, and you need to and the cluster size and all you have to decide on your own, depending on the volume of data that you're trying to process. They used to decide that 1,000 node cluster or 2,000 node cluster or 4,000 node cluster, 10,000 node cluster, like that. That depends on volume of data that you're trying to process. Okay, 4 node cluster, 10 node cluster, like that we used to have actually. Okay, now we have this Hadoop ecosystem for everything, which is satisfying my requirement, for my company requirement, I can say. Then why suddenly the Spark came into the market? Okay. So I'll tell you the disadvantages of the map reduce, how it got converted into advantage, how the Spark is actually overcoming all those problems. That's what I wanted to discuss now. Okay. So map reduce is not good for programming point of view. It is not good, guys. I told you already, Java expert people are required to do that coding actually. Okay. That is very difficult. Okay, that means they're completely depending on the Java people, which is very difficult. Okay, and one more thing is, um, required multiple chained MR steps. I'll talk about this one in the next slide. Okay, and we have specialized systems. I mean, specialized systems are nothing but like we need more and more number of slave nodes are required actually. Okay. And programming is also very difficult actually. I mean, lot of like Java coding, like we need to write. Lot of like number of lines are like we're increasing like anyway, I can say at that point of time. Okay. And performance point of view also, I'll talk about that one. Let's say how Hadoop works in the backend, let's say it takes the data from one database. Okay. And let's say we have a table here, or we have a file here, which has 20 columns or 100 columns here. From that, it selects only 80 columns, and it stores the data in a HDFS, I can say. Okay, it takes only 80 columns, and it stores that 80 columns in a HDFS. HDFS is nothing but it's one of the node in a cluster, I can say. Hadoop distributed file system. So Hadoop distributed file system is nothing but when you try to store that, when you try to upload that 1 TB of data, automatically that will get splitted into 64 MB of smaller chunks. Okay, so it will try to store that. It will take only that 80 columns, and it will try to store that in a HDFS. HDFS is nothing but again it's a disk. It's a hard disk, I can say. It reads the data from hard disk. It stores intermediate output in a hard disk. Again, on top of that one, let's say I wanted to do some aggregation. It reads the data from the hard disk again, and it performs that aggregation, and it stores again that intermediate result in a hard disk again. It reads that, okay, on top of that one, I have to do some group by. Or like having class I wanted to apply on top of that, that aggregated data. So again, it has to read the data from here, and it has to store that in a hard disk. Okay, even if multiple queries are trying to use the same data, every time you have all these people are actually have to read the data from the hard disk only. So when you try to read the data from hard disk and storing that intermediate outputs results in a hard disk, every time it has to go and read the data from this hard disk, right? That has become very tedious task for Hadoop. That means reading the data from the hard disk, again writing it back to the hard disk. That means indirectly high input output data processing is happening there. High IO is required for that. So that is what I was trying to tell you here. Okay, writes the disk between each computational step, selecting that columns, performing that aggregation, grouping the data, and everything. For everything, the disk operation is happening here, and it is expensive for the reuse of data. I mean, especially for the that machine learning algorithms is becoming popular at that point of time slowly in 2016 and 17. Slowly, the data science has also slowly coming into the market at that time. Okay, so for that machine learning algorithms, actually, it has to train the machine learning algorithms. Actually, it takes the data as an input, right? We have to train the data to that algorithms actually. That is an iterative that is an iterative process actually. So this Hadoop has become like very expensive for that iterative algorithms. Okay, at that time actually Spark came into the market. Now people started thinking this Hadoop is not giving that performance. Of course, we solved the problem actually. Instead of like processing the huge volume of data with single system, they solved actually they're trying to process that data with the help of multiple systems. Parallelly, they were trying to do that. Concurrently, they were trying to process the data. See, previously, before Hadoop, actually, only one system used to process the data. Now we have multiple systems in place to process that data. That too parallelly. So this has become an advantage at that time. And slowly, when you try to process that huge volume of data, again, it has become a bottleneck for them. The performance is became a bottleneck for them. So then market started thinking, actually, can we do better? Then actually, the Spark came into picture. What Spark does is it reads the data from the hard disk first time, okay, and it performs something. Let's say it is selecting only 80 columns out of 100 from that CSV file or from that JSON file, and it stores that intermediate result in a RAM instead of that ROM memory. Now, reading the data from the hard disk is a faster process, or reading the data from the RAM is a faster process? Which one is faster, I can say, when you compare both the things actually. When you see these two pictures here, this one and this one, in which process actually the data processing will happen quickly?
In
Second one,
RAM.
right? RAM memory, right? Now, this is the
Yes.
inspiration for the Spark people actually. So, what Spark does is it initially treats the data from the hard disk, and after that, processing will happen in the RAM memory. This is the motto of the Spark. Even if the multiple people are trying to use the same data, first it loads the data into the RAM memory. From there, anybody can use it. Okay. So that is what I was trying to say here. Okay. It is just for read-only purpose, I can say, not for writing. Spark does not store anything, guys. Spark is just a compute engine which computes the data actually in a RAM memory. That's it. Spark is not a Spark doesn't store anything. Spark is just a execution engine. It's a framework, I can say. So that idea has become. I'll talk about this RDD as well. This idea is RDD. RDD is nothing but resilient distributed data set. Okay, which is the title of Spark paper. Okay, I'll tell you a little background about that one. Don't worry. Okay, so when you say what is Spark, when you ask me like, hey, so what is Spark? It's an open source in memory. When I say fast, it's an in memory general engine for large scale data processing. It processes the huge volume of data in memory, I can say. Okay, or one more thing, like it's a distributed execution framework. Spark is a framework, guys. Actually, framework is nothing but they wrote this like the framework. Actually, framework is nothing but just a script, right? Some script. It's a script actually which does some task. So they wrote that framework in a Java language. It's not pure Java language, I can say. It's a Scala language, I can say. They implemented Spark framework in a Scala language. Okay. So the Spark interacts not only with the HDFS, it also interacts with the S3 bucket, your Apache Cassandra CFS, and the your this one Azure Azure buckets, Azure blobs, and GCP buckets. It can interact with anything, I can say. But Hadoop used to interact only with the HDFS. See, Spark is only processing engine, right? Ultimately, where do you store the data? You have see ultimately after processing, you have to store the data somewhere, right? So for that storing purpose, actually, the Spark can interact with HDFS. Spark can interact with this S3. Spark can interact with the CFS as well. Interact with other applications as well. Spark does not store anything. Okay. So the first paper was actually published by Meta Jaharia, who is co-founder of one of the co-founder of that I can say Databricks. I'll tell you the background of this one. Initially, these people actually, Mata Jaharia, Chowdhury, and the Franklin and Shankar, all these people actually started this Spark in 2010. Okay, and after that, they introduced this RDD concept in 2012. 2012. And after that, they handed over this project to the Apache company again. Because at that time, Hadoop was maintained by that Apache only, right? Software maintenance and everything. Um, like at that time, these people actually handed over that Apache Spark project or framework to the Apache company again, Meta Jahari and other people. So now this Meta Jaharia, he came out of that thing actually, and he started a new company called Databricks. Databricks is a company actually. Now he is the CTO, Chief Technical Officer, and co-founder of Databricks company. He's still there in the LinkedIn. You can check. You can check his LinkedIn profile. Okay. So what is the difference between Apache Spark and the Spark which is developed at Databricks? Is when you compare with the Apache Spark, he handed over to that Apache company and he came out and he what I can say is like he took that same framework as a reference and he improved that Spark little bit, I can say, compared to the Apache Spark. Databricks, see, ultimately the concept is same. Apache Spark, Databricks Spark, ultimately the concept is same. But compared to Apache Spark, Databricks Spark is 10 times faster, I can say. Performance point of view, I can say. Okay, they have done some tweaks in the backend. That is the reason why this is bit faster, I can say. So, see, in the Databricks also, backend they use Apache Spark only, but little different. Concept is little different. The processing is little faster compared to Apache. Okay, so that is the start point of the Spark, I can say. So why it has become like popular is when you compare with the map reduce, if it is processing actually in memory processing 100 times faster, I can say, compared to map reduce. Okay, that means with the help of map reduce, if you're trying to process 1 TB of data within 100 minutes, 1.5 hour, with the Spark you can process within a minute that 100 TB. Even if you think disk point of view, consider like Spark is actually performing these operations. Even if you compare with that one, it is 10 times faster, I can say. And it is scalable, of course. Any number of systems we can add. When I say any number of systems here, I'll tell you the architecture. At that time, you'll understand the meaning of the scalable point. Okay. And it is used by many of the companies, I can say. Amazon, what every company is almost using that one. Uh, Apache Spark, I can say. And it's not hard at all. And it's not hard at all because in the map reduce, they used to use only Java programming. Now here in the Spark, we can code in Python, we can code in Java, we can code in R, we can code in Scala as well. Okay, whichever the language is comfortable for you, you can use that. I'll talk about this language concept also a little later. Okay, so the conclusion point is the Spark actually started in 2009. I mean, started means initially started in UC Berkeley in 2009. It actually came into the market in 2013-14 time, I can say. Okay. It is 10 times faster than 10 times on disk or 100 times faster than the map reduce that they used to have. And it is very good for the iterative machine learning algorithms. And it provides high level APIs. I'll talk about that APIs from the next week actually. It provides high level APIs in Java, Scala, and Python. Okay. It can integrate with the existing Hadoop environment. That means it can write the data to, it can interact with the HDFS. Okay. So if you want to know more about that one, this is the website actually, spark.apache.org. You can refer that. Okay. So any questions so far? I know this is theory. It's boring. I'll not take much time here. I mean, I thought I can just give you at high level background. So that is the reason why I discussed all these things. Any questions before I move on to the architecture part?
Siva, traditional databases also coming using RAM memory only, right?
Not all the traditional databases, I can say. Only few databases used to use the TRA memory. Not all. If you take Oracle, like how this. Um, okay, that is different one. I don't want to talk that one. Yeah, that is okay. Yeah, go ahead. Are we good? Okay, so if somebody asks you to compare between the MapReduce and the Spark, right? The processing location is in memory in Spark, but the same thing actually happen in disk here. Okay, it reads the data from disk, and again it has to store that intermediate data in a disk. Again, from there it has to process that. Again, it has to store that intermediate result in a disk. So disk to disk operations will happen here in the MapReduce. But in Spark, everything happens in memory. So it is bit 100 times. That is the reason it is 100 times faster than the MapReduce. And here we are completely depending on the Java language. But here we can use either Scala, Python, Java, R, anything we can use here. Okay, speed point of view, 100 times faster. It is very slower. Latency point of view, it is very lower, higher here. Computation, iterative computation is possible, but it is not possible in the Hadoop actually. This is mainly data science application, I can say. Okay, so task scheduling, Spark actually, task scheduling in the sense it's not like the job scheduling part, I can say. Internally, it schedules that, creates the task actually. So for that, Spark manages that internally. But here, external schedules are required. That means ARN is required actually. I was talking about the ARN, right? That ARN is required here. But Spark, here, the Spark can manage everything internally. Okay. Now tell me with this knowledge, if at all, if you want to, okay. The Spark framework is actually completely built on top of Scala language. Scala is actually derived from Java language. Now, if at all, if you want to work with Spark, what is required in your system?
Java, JVM.
Java KD.
Yes. Yes, exactly. Java is required. Without Java, you cannot run the Spark. Okay? Yeah. Uh, okay, let's get into the architecture part. Try to put your 100% focus on this one, guys. Because if you understand this one, it's very easy to like answer some of the interview questions actually. Okay. Huh. Here also, Spark also follows actually master slave architecture. Uh, so we will submit that driver program. We will submit that whatever the program that you wanted to execute. We will submit that one to the master, I can say here. Okay, that is the driver program, I can say. Whatever the code you write in Python or Scala or R in Java, whatever you want, you can write it actually. That is the driver program. That driver program actually backend it initiate the Spark context. When I say Spark context, it is as equivalent or like as equivalent as your SQL session. Okay. So let's say like when you want to execute some queries, right? In Oracle or in SQL Server, what do you do actually? Once you connect to the SQL Server, what do you do? Right click on that, but okay, sorry. Right click on that particular database and you'll open one worksheet, right? Even in this like this one also like our Snowflake also we do the same thing, right? If at all if you want to execute something, what do? You'll create a session or not? Same way, it is going to create actually Spark session in the backend, Spark context. Okay, so that initiates the Spark context and it handovers that program to the cluster manager. Okay, what this cluster manager does is it actually maintains the different slaves here. Okay, in a cluster, you'll be having hell lot of like systems, I can say. It can be like 20 systems, 30 systems, 60 systems, 100 systems, 1,000 systems also. It can have 1,000 systems as well. Okay. Now this cluster manager has to go and talk to each and every node, slave node, I can say, and it has to divide the task into, it has to divide that entire program into different tasks, and it has to hand over that each task to each node, I can say. Okay. Here, each node, we call it as a executor here. My statement is little bit wrong here. I'm telling you. I'll tell you why I'm saying it is a wrong here. Okay. So, uh, you'll be having actually different slave nodes. In each slave nodes, you'll be having executor also. I'll talk about that one little later, not now. Okay. So for now, you just try to understand. Yeah, all these executors are nothing but slave nodes. Okay. Each slave has some cache. Cache is nothing but your RAM memory, and each slave can execute one task. I'll change my statement later. For now, you just try to understand each worker node or each slave node has some RAM memory and it can execute one task. Like that, you can have any number of systems here. 4 node cluster or 8 node cluster or 10 node cluster. So one master you'll have here, or any one of these slave also can act as a master and others can act as a slaves here. So cluster manager chooses that actually. It choose one of these slave node as a master and rest of them it will try to treat as a slaves. And that master will assign the work to each slave node. Getting my point here? Okay, let me talk about one by one here. Driver program is nothing but I told you already. The program which initiates that Spark context. I can say main function. I can say cluster manager is nothing but it allocates the resources. So cluster manager is nothing but ARN is also one of the cluster manager. Apache Mesos is also one of the cluster manager. Nowadays, you don't need to deal with all these things, guys. You don't need to deal with. Everything is managed by cloud only in the backend. You don't need to manage all these things. Only for understanding, only for the terminology, we are trying to understand all these things. Okay. Executor is nothing but it's a worker node or slave node, I can say. That runs a task. Task is nothing but one job. It's not a job, I can say. It's a small job, I can say. Okay. Job is different word actually. In a Spark terminology, job has different meaning actually. That is the reason why I'm a little bit hesitate to use that word job.
Action.
Action, I can say, yeah. Okay, which can perform action. Okay, task is nothing but a unit of work, I can say. Okay, job consists of multiple tasks. That is the reason why I was hesitant to use that word job here. Job is nothing but it's a combination of different tasks, I can say. I'll talk about that one maybe tomorrow on. I'll show you how it is dividing in the backend, how each job is dividing as a task. I'll show you that one. In the Spark UI, you can see all those things clearly. Okay, each job is divided into smaller tasks called stages. Each stage is actually called as stages. Okay, Spark context is nothing but it's a kind of session, I can say. I'll talk about that one also. Okay. So this is what I was talking, guys. Actually, the architecture part, like this is master node, I can say. Master node will go and interact with each and every worker node. Hey, you do this task, you do this task, you do this task, you do this task. Like that, it will go and interact and try to assign each task to each that slave node, I can say. Okay, so let me talk about that uh, the architecture a little bit deeper. So this is PySpark driver, I can say. I mean, I'm talking with respect to PySpark here, because we are going to we are going to like understand this Spark in Python only mainly. I'll tell you the reason also why we are trying to understand only in Python, why not in other languages. Okay. So first we'll talk about that one. So PySpark driver, I told you already, the driver program is responsible for generating that Spark context or Spark session, I can say. Okay. So uh, I told you right al- already, Spark runs. Spark is actually built on top of Scala. Scala is built on top of Java language, right? So Python directly it cannot run actually. So we have here Py4j, which can convert the Python into Java objects. That means indirectly we are submitting here Python objects here. That Python objects cannot be understandable by your Spark. So that is the reason why we have an intermediate converter internally. See, you don't need to do anything with this one actually. In a Spark, actually, we have Py4j, Python for Java. The meaning of this one is Python for Java. That means it converts the Python objects into Java objects. See, I told you, right? Spark understands only Java objects, not the Python objects. Okay. So again, it converts the Python objects into Java objects here, and it actually executes in the backend RDD. It uses that mechanism. I'll tell you what exactly mean by that RDD and how it looks like and everything. We'll try to see from tomorrow. Okay. So it submits that one to the master node. It submits that program. It initiates that session and it will submit that one to the master node. Master node will go and interact with each and every worker node. And I'm telling you here, inside each slave node or worker node, okay, we have different executors. This is what I was telling you. Executor is not a correct word here, I can say, in the actual architecture. So this is the actual architecture, I can say. In each worker node, you'll be having executor. I'll tell you what exactly mean by these executors. Okay, each worker node has different executors. Okay, now let me talk about what is executor. Okay, so here, see here, let's say this has 60, this worker node is nothing but a system, right? Each system is a either dual core or quad core or octa core or 16 cores, right? It can have the 16 cores, right? Okay, so that system can have like 8 GB of RAM, or 32 GB, 16 GB of RAM or 32 GB of RAM, right? Now, executor is nothing but, let's say it has 32 cores. Consider that one, 32 cores and 32 GB of RAM it has. Okay. So 4 cores, 4 GB is nothing but actually one CPU here. Okay. Is nothing but executor. That means that 4 cores and 4 GB memory is a unit, I can say. It's a unit, I can say. That's we call it as an executor. It can execute one task. That means what I mean to say here is one worker node or one slave can execute multiple tasks parallelly. In the previous architecture, I told you, okay, I told you each slave node can execute one task, right? But now I'm telling you, I'm changing my statement here. Now I'm telling you, each worker node can execute the task parallelly, because inside each worker node you have executors. Each executor can execute one task. Getting my point?
Yes. Is there any, how it will decide how many executors we should present in worker node? Or
Yeah,
it's
I'll
based on
talk about that one
performance?
also tomorrow. How many executors?
Mhm.
How it will decide? That's what you're asking, right?
Yeah, yeah.
That depends on the volume of
System.
data that you're trying to process,
Okay.
and that depends on the settings that you do in the Spark.
Okay.
Each executor only one task or multiple tasks?
Each executor can perform only one task.
Only one task.
One task, yeah.
Worker node perform multiple executors.
Multiple, yeah. Worker node can execute multiple tasks.
Multiple executors.
It has multiple executors. It can execute multiple tasks. Worker node at high level, worker node can contain multiple executors, right? Worker node can execute multiple tasks, right? In that case,
Yeah.
Hmm.
From executor, only one task.
Correct. And this is the ecosystem of the Spark, guys. Now everything is gone. I mean, in the Hadoop, whatever we have seen, right? For batch processing, we have Storm, and for sorry. For streaming, actually, we have Storm. For batch processing, we used to have MapReduce, right? Now, like the ecosystem got changed. Now, for batch processing, actually, we have Spark SQL. For streaming, actually, we have Spark Streaming. For machine learning algorithms, actually, we have mlib for processing that machine learning algorithms. For this one reporting purpose, we have graphics, and we have third-party activities also we can perform on top of Spark. So Spark can interact with Hadoop, Spark can interact with Amazon, Spark can interact with the Apache HBase, Spark can interact with the MySQL, Spark can interact with the Elasticsearch in Amazon, and Spark can interact with the Azure and the GCP as well. So it reads the data from all these storages, and on top of that one, it extracts the data from using the data source APIs like spark.read.csv, spark.read.json, XML, like that. We have different APIs out there. So using that APIs, it will read the data from all these sources. So these APIs backend runs. They generate actually RDDs in the backend. On top of RDDs, actually, we have data frames. This is what we are going to understand in this Spark course, actually. We are going to study about the data frames only, data frame APIs. There are like 40 to 50 APIs are there. If you understand about that 40 to 50 APIs, that's all you're done with the Spark. They're very easy. If you know SQL, they're very easy. Okay, using same data frame APIs, actually, you can perform Spark SQL, Spark streaming, machine learning algorithms, and you can build reporting as well here, and third-party libraries, third-party activities as well. So you can do all these things using Python, Java, or Scala as well. Any of the language you can use here. The mostly used language is Python now in the market. I'll talk about that one, why it has become popular.
Okay, sure.
Okay. Yeah. That's all for today.
శివ ఎగ్జిక్యూటర్ కి అది ఎంత ర్యామ్ ఎంత అది ఎలా తెలుస్తుంది శివ వాళ్ళు
We have to
డిఫరెంట్
set, we have to do that setting.
సెట్టింగ్స్
Mm-hmm.
అంటే ఇవి ప్యానల్ గా సేమ్ ర్యామ్ పెడతారా లేకపోతే డిఫరెంట్ ఈచ్ ఎగ్జిక్యూటివ్ కి డిఫరెంట్ డిఫరెంట్
No, same
ర్యామ్స్
ఉంటుంది. Same.
సేమ్ సేమ్
Same. Mostly it is same size. They maintain same size for each executor.
ఇది పై4j అనేది ఇట్ విల్ కన్వర్ట్ స్కాలా టు పైథాన్
No, Python to Java objects.
పైథాన్ టు జావా
Mm.
ఓకే
Because you're interacting with Python language, right? Backend it converts actually that into Java objects.
జావా ఆబ్జెక్ట్స్
But we won't know, right? This and all
We
things
don't know
in the
all these
back
things.
end.
That is internal to Spark. We don't do
It's
anything with Py4j.
it's just a knowledge. That's it.
Knowledge, yes.
Okay, sure.
Okay. Yeah, that's all. Tomorrow I'll show you like um I'll show you how to install this Spark in your local. So do not create any Microsoft account or Amazon account, guys, at this point of time, because you have to understand all these concepts thoroughly in your local. then only we'll for database concepts we'll move to the cloud actually, not now, I can say.
Okay, sure.
Okay. Mm. Yeah, that's all, guys. If no questions, we can wind up.
Yeah, thank you.